So today we discuss an optical instrument. So in our syllabus, that instrument is a microscope. First instrument is microscope. Optical instruments. And we discuss microscope. Okay. So what is a microscope? Microscope is a simple magnifier. Okay. So image will be magnified. Okay. Highly magnified. Okay. So for a simple microscope, design a simple microscope with the help of a convex mirror. Okay. So keep in mind that image will be magnified. Okay. That's keep in mind, the microscope image will be magnified. Okay. And you see that in your college biology lab, you see that a microscope and see that is a bacteria, suppose amoeba. We see that a very small or tiny particle, we can't see the naked eye, but in microscope we see that. Okay, a single cell, epithelial cell, okay, blood cell, we see that with the help of microscope. So actually microscope is a tiny object will be highly magnified. So I draw a simple microscope with the help of a convex lens. That's the principal axis, and here the object is far near that pole. Okay, so there is an object, and that's a incident ray parallel to the principal axis. After falling here, it passes to the second focus or secondary focus here, and we need another point. So that's why we need another ray passing from pole. And you see that very carefully, these two emergent rays actually diverge. Okay, so they do not meet here. So when I see that in that eye place here, so you see that the rays diverge, do not meet. So now if I draw a backward line, suppose these two rays are backward. Actually these are virtually draw backward, and you see that that's the cut point, and here the image is here, that the image, and that image is a virtual image, virtual, erect, and highly magnified, highly magnified. And you see that if a image height h dash and object height with the h, and you see that magnification, that is h dash by h, and h dash is very greater than, much greater than h. So that's a highly magnified. That's a simple microscope. Okay, with the help of convex lens. Design a simple microscope with the help of convex lens, and that is a image distance v, that's the object distance u, and we need, for good microscope or highly magnification, for highly magnification we need u very small. Okay, the object distance is very small and v very high. Image distance is very high for good microscope. Okay, and now we draw some magnification formula here. Now we derive some magnification formula here. So we know that m, that is equal to h dash by h for image height, that's the object height, and also the m equal to v by u. And we know that from thin lens formula, that is 1 by v minus 1 by u equal to 1 by f, and 1 by u equal to, we get 1 by v minus 1 by f. So v by v minus v by f, so cancel these two terms. So 1 minus V by F, that's the magnification. So you see that image is left side. Left side means in front of lens. Okay, so image is front of lens for Cartesian sign convention. So that is a positive, negative x direction here, and that's a positive x. So if that is image is negative x, so that's why B is a minus, and we say that is a, if this distance say that is a D, so that is equal to call a minus D, that is a B. Okay. B sign convention, that is a negative. So now we get 1 plus minus minus the plus, that is D by F, that is a magnification, that's a linear magnification. Magnification. Clear? What is linear magnification and derivation, the formula? Okay, actually see that there's an image distance B, that's very dependency here. But object distance in NEET, if object distance is very less, so image distance is automatically, if U is very less, so V automatically very high. Okay, that's the linear magnification. Okay, and when you derive that, another magnification is called angular magnification. For case of angular magnification, for angular magnification, okay, so that is equal to M, that is called angular magnification, that's the image angle by object angle. So here now we draw some angle subtended by a object. Now we draw, no, draw angle subtended by object, so that that's the height of H, and suppose this angle we say that is a theta 0 for object, and that distance is say that is a D. Okay, so now we apply that is a tan theta 0 for object. Okay, and we need a very important concept here, that is for single lens simple magnifier, that is a single lens. Okay, this is called a single lens simple magnifier, this is called single lens simple magnifier, simple microscope or magnifier. Okay, that is tan theta naught. Keep in mind that is tan theta naught, and let's achieve that the object we brought closer to that eye. Okay, closer to that eye than D. What a single lens magnifier they achieve is that they allow the object to be brought closer to the eye than D. So that's a tan theta naught, or called theta 0, that is equal to H by D. Okay, and then equation number 1 you say that, and that is for small angle approximation, that is theta naught H by D, and here the image is suppose the magnification on the image is an infinite, so we obtain that angular magnification. Okay, when the image is at infinite, when you get angular magnification, when image is at infinite, then time we get angular magnification. Okay, now so image is that infinite means that convex lens is single lens magnifier, so place a object at focus. Okay, so now incident ray parallel to the principal axis passing through that secondary focus or second focus, and you need another point, so that's why passing to that pole, but these two line be parallel, so they actually meet infinite, virtually meet infinite. So now that height, this height be the h, and that is a theta I image, and here be the theta I image. For that angle belongs to that image, and you see that is our naked eye. Okay, so now tan theta I, that is equal to, and obviously this distance, okay, this distance is f, because object placed at focus. So that is a tan theta I, that is perpendicular this angle, perpendicular by base is the f, h by f. Okay, that's the equation number 2. And for small angle approximation, that is equal to theta I. For angular magnification, we know that is m equal to for case of angular theta I by theta O. So angle belongs to the image by O. So here theta I, that is h by f, and theta O means object, that is h by d. So finally we get that is h with the cancel, that is d by f, that is a m. As for angular magnification, d by f. And another way you can prove that for case of angular magnification. Okay, so way is like that. We know that m, that is m equal to the magnification, that is h dash by h, image height by object height, and m, that is image distance by object distance. Okay, and here you see that tan theta I, okay, that is equal to, if I that is belongs to the image, that is image height h dash by that image distance, and that image distance is far behind backside. Okay, that is a minus v. And here if I these to be the equal, so that is v by u, so h dash, this h dash replaced by h v by u, that is h v by u, and that is a minus v here, so v with the cancel, so we get tan theta I, that is equal to h by minus u. Okay, for small angle, that is theta I equal to h by minus u, and if u also the left side, and that is equal to, we get u equal to minus f. So that is theta I equal to h by minus with the cancel, h by f, that is h by f. And now put the theta I here, and theta object we know that h by d, and put these two, you get a angular magnification. That is design a simple microscope with one lens. Okay, but here is some limitation here. The limitation is, in that case, the limitation is, there is some limitation, there is some limitation is the single lens, simple magnifier or simple microscope, the magnification is less than equal to 9. Okay, for larger magnification, and we use two lens. For there is a limitation, for larger we need a highly magnification, for you need two lens, need two lens, and these two lens are compounding effect, the image effect, the compounding effect of image. Okay, the compounding effect, the two lens create a compounding effect of image. Okay, so that is known as compound microscope. This two lens microscope is known as compound microscope. So next we discuss what is compound microscope. That's a compound microscope, and for overcome that limitation, the magnification is less than 9. Here we get a magnification far better. And here you see that for compound microscope, okay, so these two lens here. So one lens, the first lens is called objective and second lens is called eyepiece. Because the eye is placed here, that's why these are called eyepiece. Okay, and that object place, there is the object. Okay, and that's the incident ray. After the striking that objective lens, they passing to that this ray, and we need another ray from object, and this ray meet here, and the H dash is the first image created by the objective lens. So H dash is first image created by objective lens. Okay, in board exam, drawing these compound microscope is very important. Okay, and yeah, alternate year you get this type of question, drawing a compound microscope or telescope. Okay, so please drawing this practice. Okay, please practice this drawing, and that is very easy actually. Okay, if I these two meet here, that is a dash top and that is a B dash, that's the first image, and these two angle be the same. These are the vertically opposite angle, so that's why these two angle be the same. So we need a magnification. So magnification for objective, so that is equal to H dash by H. So that's the height is H dash, that's the H, that's for object, and that's here the image, and the lens is objective lens, and that is almost equal to L, this length from that point. Okay, secondary focus of the objective to that is first focus of the eyepiece, that is L by and F naught, L by F naught. Okay, focal length of the objective. Okay, now here you get a important question for 1 marks in board exam, that is a tube length. Okay, what is tube length? So tube length is that a secondary focus of objective lens to the length between secondary focus of objective to primary focus of eyepiece. Okay, and this is called tube length. Okay, tube length of compound microscope. And here you see that this image, that is is an image actually created near to the eyepiece. Now see that magnification of the eyepiece lens, so that is ME, and that is, see that the eyepiece create image here. Okay, so now the distance is from image, second image to that eyepiece lens is called D. Okay, so that is equal to magnification formula. You see that M equal to 1 plus D by F. So 1 plus D by F here. Okay, and here the image is first image is obviously inverted image, and here this eyepiece also created inverted image. Okay, that is D by F, and if D is if image created infinite. Okay, if image created infinite, so D is very large. So image at infinite, so D is very large. If D is large, so ignore 1 plus D by F. So we will pretend ME equal to D by F. That's a magnification of eyepiece lens. That is a D by FE. sorry, sorry, that's the obviously the FE, focal length of the eyepiece lens. Okay, and now previous class we discussed magnification. Two thin lenses are in contact. What is the magnification? Magnification should be multiplied. So here the effective magnification, that is equal to magnification of the objective lens and magnification of eyepiece lens. So okay, so total magnification or effective magnification, that is MO, we get L by F naught, that is L by F naught, and ME, that is D by F naught. Okay, and that is equal to M. These are the magnification of compound microscope. Magnification of compound microscope. Okay, clear. So what is the magnification compound microscope? For good, for better magnification or good magnification, uh, good magnification, we need, and see that very carefully. If not, sorry, that's the FE. Sorry, that is ME D by FE. If not, focal length of that objective lens and focal length of the eyepiece lens should be very small. If not and FE is very small, and if F0 and FE are small, or F0 and FE are small, so L should be large. Okay, large. So if L should be large, automatically M should be higher. So more good magnification, for more magnify here. For good magnification, F0 and FE, focal length of the two lenses should be small, and L should be automatically makes large. Makes large. Okay, that's a compound microscope. The working of the compound microscope, and keep in mind this drawing is very important for board exam. In alternate year you get this question. Okay, for 2 or 3 marks question, 1 to 2 times are we practice, and for understanding this, what is the objective lens and what is the eyepiece lens, how to calculate the magnification of this compound microscope, that should be very easy to remember. Okay, so do not skip that part. Now we discuss a telescope. The telescope is another instrument, optical instrument. Okay, in our syllabus, that's a telescope. The optical instrument in our syllabus. So the angular magnification of the distant object. Here we study the angular magnification of distant object. It has the objective and eyepiece. So here the two lens, objective and eyepiece. So here the difference of compound microscope and telescope. You see the compound microscope, objective, okay, aperture length of the objective is lesser than eyepiece, and here in telescope, objective aperture is much greater than eyepiece. There's the objective lens and that's the eyepiece lens. Why these are called objective? Because the left side in front of lens we have an object, and there's the eyepiece. Why? Because these are our eye I place here and see that is a image. So that's why this lens is called eyepiece. Okay, so here objective aperture is much greater than eyepiece aperture. Okay, so here from derivation, that is M, and the M is the angular magnification, that is equal to beta, this beta by alpha. Okay, and what is the beta? From derivation like a tan beta. So tan beta, that is equal to, that is at okay, that is a H. So tan beta, that is equal to H by Fe, resistance Fe, this triangle, tan beta. And now tan alpha, this triangle for tan alpha, that is also equal to H by F naught. These two lengths is F naught. For small angle approximation, tan beta is equal to beta, approximately equal to alpha. So now magnification equal to beta by alpha, h by fe by h by f naught, that is equal to f naught by fe, that is equal to magnification. Okay, the focal length of that telescope is so focal length of telescope, okay, that is equal to f naught plus fe, and the magnification is, that is f naught by fe. Okay, for beta magnification, so m is inversely proportional of 1 by fe. So fe should be small and m directly proportional to f naught, and the objective focal length should be high. Okay, for like a terrestrial or astronomical telescope, terrestrial or astronomical telescope, so f naught should be high, so f naught look like 100 centimeter, and fe, that focal length of eyepiece, that is almost 1 centimeter, that is a 100:1, that's very small, so the magnification, that is 100, so 100 times magnify the object, so 100 times magnify object. Okay, that's a astronomical or telescope or terrestrial telescope. So if that is a good microscope, that is a f naught equal to 1 meter and f is suppose that is a 1 centimeter, so we get a magnification, we get 1 meter means 1 meter, sorry, we get 10 meters, suppose we get 10 meters, so 10 meter means 1000 by 1, so get 1000 times magnified if the object is 1000 times magnified here. Okay, so now we discuss another type of telescope is called reflecting telescope. These are called reflecting telescope. Reflecting telescope. Okay, so here is the object is an infinite, object is infinite, okay, far, okay, far light years, okay, very large distance, so that the incident ray for this objective mirror, and after striking they back to the secondary mirror. When they back to secondary mirror, after striking secondary mirror, he then strike the eyepiece, and similar here, after striking incident ray, strike, then strike and meet eyepiece. And here this type of reflecting telescope, we get a very far light year distance object, we see that in our naked eyes, actually not naked eyes, actually with the help of telescope. Okay, telescope actually help us to distance a far distance. Okay, in India, the largest telescope in India is at Kavalur, Tamil Nadu. Okay, there's a this largest telescope. Indian Institute of Astrophysics in Bangalore set up a telescope here. Okay, large reflecting telescope would be pair of the Keck telescope Y for USA. That's a 10 meter in diameter. 10 meter in diameter means a very large. Okay, 10 meter in diameter is a very large. Okay, so that's why this reflecting telescope is more powerful than refracting telescope, and this telescope is called refracting telescope. Telescope, and this is reflecting telescope. Okay, and this is called a compound microscope. Clear? Summary of today's class. So summary, start discuss optical instrument. Optical instrument. Okay. First study single lens microscope. Okay, and compound microscope. Third, telescope. There are two types of telescope: reflecting telescope, and that is a refracting telescope. Okay, and that's that a reflecting telescope, and here we will discuss is a refracting telescope. So today end the class here. If you have any doubt, please ask in comment section. I will try to give the answer. If you have further more doubt, please mail me. I will try to give the answer. So next class we meet again a new chapter or new concept. Thank you.